Level problems. Consider a situation in which we have a metallic coin which is placed on a wooden block and the block is floating in a liquid. Now imagine you picked up the coin and you are dropping the coin in the liquid and the coin got sink deep in the liquid. Now you have to compare what will be the effect on the level of the liquid in the container and what will be the effect on the level of the wooden block that is outside the container. Effect means whether this level will rise or fall or will remain unchanged. So there will be many situations, many problems involving such level considerations. Like suppose if I say you have a boat and there is a large iron ball in the boat and the boat is floating in the river. Now you pick up the iron ball and throw the iron ball in the river. What will be the effect on the level of the liquid in the river? So all such problems involve the consideration for the level of liquid and the level of the solid inside or outside the liquid. In today's lecture, we will see the fundamental logic governing the comparison of such levels so that once you understand the fundamental, you can solve any kind of problem. And then, of course, we will see some of the FTP fingertip points for solving MCQs or numerical type problems. Okay. Now, let's see what will be the fundamental approach. Suppose we have a block of mass M and this block is floating in some liquid, a fluid usually say a liquid, and we have a liquid container and say the density of liquid is rho L. Okay, the density of liquid is rho L. So this is the liquid with a density of rho L and the block is floating. It means the density of the block is of course less than the density of the liquid, then only it can float, and there will be some portion of the block inside the liquid. Let the mass of the block be m and the portion inside the liquid be vi. That is the volume immersed inside the liquid. Now we know from the fundamentals of fluid statics, there will be an upthrust acting on the solid which will act upward, and this will be equal to the weight of the liquid displaced by the solid, that is the volume of the object inside the liquid, the density of the liquid into g. This is the fundamental we did in fluid statics, how to find the upthrust. Now suppose you want to remove this solid. Now when you remove this solid, it will free some of the volume. It will actually free the volume which is occupied by it. Right now it is occupying a volume vi. Okay, so when we are lifting up the solid or we are removing the solid, let the volume which get free be delta v void. That is the void volume, that is the volume which will get free. So how we can find the free volume? Simply this volume will get free. So if I'm writing the free volume as delta v void, so just imagine for the time being, if you want to visualize what will be this free volume like, so just imagine you have lifted up the block and for the time being just imagine that the liquid is frozen, so the liquid will not move to fill the empty space. So if the liquid is frozen, though it will not be frozen, we are just considering a model to get a better clarity and understanding. So this much volume will get empty, correct? So this I'm writing as delta V void, correct? This is the delta V void. This will be the free volume that will be created by lifting up the solid. Clear? Now see what will happen. This is the model in which you have imagined the liquid is frozen, but actually in reality, the liquid is not frozen. So as soon as the block is lifted up, the liquid particles will come to fill up this volume. And in filling up this volume, the level of the liquid will decrease, correct? So the liquid will come to fill this volume up, maintaining a same level. So in doing this, the level of this liquid will decrease. So this volume is responsible for decreasing the level of liquid, correct? This volume is responsible for decreasing the level of the liquid. So it is very simple, a common sense. If simply you have removed this block and doing nothing else, then this height of the liquid in the container will decrease. Okay, So first, in all the problems, you will consider when you are removing anything, any solid object. So what is the volume being created? What is the volume which is getting free from the solid for the liquid to get filled up? This volume we are calling void volume. Okay. Now let's see. Now suppose in the same container, in the very same container, what you are doing now, you are putting some solid. The solid may be partially present in the container. Of course, if the density of the body is less than the density of the liquid, or the solid body may be deep inside the liquid, that is, it will get sink in the liquid when the density of the body is greater than the density of the liquid. So in both the cases, this solid body will displace some volume of the liquid, correct? It will displace some volume of the liquid. And this volume, we are calling it delta V displace. Now, we can find the displaced volume. If it is partially immersed, you can find it by upthrust. Like in this case, delta V displace you have to find. So it will be equal to the weight of the object. So you can write mg is equal to delta V displaced into density of the liquid into g when the body is floating. In this case, since the whole object is completely inside the liquid, so delta V displaced will simply be the volume of the body, correct? Because the whole body is inside the liquid. So whenever you are throwing something, some solid object in the liquid, there will be some volume of the liquid which will get displaced, which you can find by Archimedes' principle, equating it the upthrust with the weight, or you can find by simple logic, if it is completely immersed, the displaced volume will be equal to the volume of the body. Now this displaced volume will be responsible for increasing this level of liquid, correct? This displaced volume will be responsible for increasing this level of liquid, correct? So we got two volumes. Whenever we will be doing the problem, we got two volume. One volume is the volume which is getting free. One volume is the volume which is getting free after the removal or lifting up of the solid from the liquid, that we called delta V void, and this is responsible for decreasing the height of the liquid in the container. Another volume is the volume which will be displaced in the liquid when you are putting some solid object inside the liquid, and this volume you can find when the body is partially immersed. You can find the volume by the upthrust principle, and when it is fully immersed, you can find the volume by equating it with the volume of the body. Now this volume will be responsible for increasing the height in the container. Okay. Now we have to find what will be the net effect on the height, correct? We have to find what will be the net effect on the height. So suppose originally the height is h, correct? And this is some solid, and there is another object, say B is kept on it. And what you did right now, just I'm not doing any particular problem, I'm just telling you the fundamental or the logic. So you have removed this object B, so surely this block will come little bit towards the upper side. Now we have to find what will be the effect on H. So you will find both the volume, if suppose this block is left in the liquid. So we will see in the coming problems, we will find both the volume. First, the volume which is getting free, say delta V void, and this is responsible for decreasing the height. And then the volume which is getting displaced, and this is responsible, as we have seen, for increasing the height. Now, what will be the net effect on the height? This will be decided by the relative magnitude of these two volumes. If both the volumes are equal, delta V void is equal to delta V displace, then there is no change in the level of the liquid. H will remain same. If delta V void is greater than delta V displace, correct? So what do you think? This volume is greater, so the decreasing level effect is more than the increasing level. So H will decrease. Down arrow means H will decrease. And if delta V void is less than the delta will be displaced, so it is increasing the height H, so your height will increase. So in all the problems, no matter what type of problem we have, we will apply this fundamental approach, which is simple, the knowledge of density, mass, volume, and upthrust. Now let's see some of the illustrations. See, in type 1 problems, we will explore floating to floating case. Okay, floating to floating case. Like imagine a boat which is floating in a river. Now I'm making a river model like this. And say we have a boat and the height or level of the water in the river be H. And this is your boat. There's no water inside the boat. So the boat is floating in the river. This is a boat, and there are some wooden balls. There are some wooden balls inside the boat. And say the level of the boat inside the water, this level be L, and this level, the level of the water in the river be H. And in this case, we are having a floating to floating case. That is, we are having the objects whose density is less than the density of the liquid. In this case, we are considering water. The liquid can be any liquid. So when we have a floating to floating case, the density of the object is, of course, less than the density of the liquid. Now, in this case, the upthrust acting on this system means the system of the balls and the boat is equal to the combined weight of the balls and boat, correct? That is simple. Your Archimedes principle and Newton's law, it is floating, it is in equilibrium. So upthrust is equal to the weight of the balls plus the weight of the boat. Now suppose what you did, you removed all the balls. Okay, you have removed all the balls. And see this situation. You have simply removed the balls right now and doing nothing else. So when you will remove all the balls, surely the boat will get lifted up, because now the system has lesser weight to be balanced by the upthrust. So your boat will get a little bit lifted up, correct? Like this. So surely you can say the level L, this level L, that is the level of the boat inside, the level of the boat inside the water will decrease, correct? What we are doing, this is, I'm considering case A, balls are removed, okay? Simply the balls are removed. Now we have to find what will be the effect on H in this case. What will be the effect on H? Whether the H will increase or decrease or will remain the same. So when you are removing the balls, some volume which was earlier occupied by this system of balls and boat will get free, correct? Some volume of the liquid which was earlier occupied by the balls and boat will get free. Let us say the volume which is getting free is delta V void, correct? The weight of the boat is still acting. The weight of the boat is still acting. So only that volume will get free, which will correspond to the upthrust, which will be balancing the weight of the wooden balls, correct? Only that much volume will get free, which will attribute or correspond to the upthrust balancing the weight of the wooden balls. So say the weight of the wooden balls be, I'm saying the weight or mass of the wooden balls, combined mass of all wooden balls, say we have mass of B. All the balls, whether they're 3, 4, 5, no matter. Okay, so now if you apply that upthrust is equal to, that is the weight removed, only that much volume will get free. So delta V or first let me write, this will be mb into g, and upthrust will be the volume getting free, delta v void into density of liquid into g is equal to mb into g. G will get cancelled away, so I'll get delta v void is equal to mass of the balls divided by density of the liquid. This is the volume which is getting free. Is there any volume which is getting further displaced? No, because in this case nothing is being thrown in the water. I'm considering case A. You are simply removing the balls and not throwing anything in the liquid. So only the volume is getting free. And if the volume is getting free, so we have seen whenever the volume will get free, it will decrease the level of the water. So in this case, when you will simply remove the wooden balls, L will decrease already we have seen, because both will be lifted up. So in this case, you can say L will get decreased. I'm putting the down arrow, and H will also get decreased. This level H will also get decreased, correct? Because the volume is getting free when you're removing the wooden balls. So when you're removing the wooden balls, both L and H will decrease. Now let's see the scenario. Another case, if I say what I'm doing when I'm removing the wooden balls, at the same time, I'm throwing all the wooden balls in the same river. Okay, when I'm removing the wooden balls from the boat, I'm throwing all the wooden balls in the same river. Okay, so let's see what will be the effect on H and G in this case. So suppose there are 3 balls and they will be floating, correct? They will float because the density of the balls is less than the density of liquid. So already we have seen the level of this boat will decrease because now there is a decrease in the weight of the system. So boat will get lifted up. So L will decrease as in case A. This is a case B. This is case B where we are throwing the balls. We are throwing the balls in the same river. Okay. So L will decrease. Okay. Now what will be, because of the lifting up of the boat, there will be some empty volume created that we already calculated in part A. That empty volume void is the mass of the balls divided by the density of the liquid. Now in this situation, there will also be a volume displaced because now you are not removing and taking away the balls, you are throwing the balls in the liquid. So when you throw them, they will be floating in the liquid, so they will be displacing some portion of the liquid. And let the portion displaced be delta V displaced, and if we apply the principle that upthrust will be balancing its weight for finding the displaced volume. So upthrust will be equal to the weight of the wooden balls, and the upthrust will be delta V displaced density of the liquid into G is mb times of G. Now G will get cancelled away and you'll get delta V displaced is equal to mass of the balls divided by density of the liquid. Now you can see from equation number 1 and equation number 2, the volume which was getting empty by removing the wooden balls from the boat and the volume which is getting displaced by throwing the wooden balls in the boat are coming to be same. And since they are coming to be the same, there will be no effect on the level of H, that is the level of liquid. This is very interesting thing, correct? So whenever, no, this is called the floating to floating condition. This is called the floating to floating condition. Whenever some body is floating in the liquid and there is some another object on that object, that floating object, and you're picking that object and you're throwing it in the liquid, and that second object is floating in the liquid, so there will be no change in the level of the liquid. That you can remember as a fingertip point. Okay, this you can remember as the fingertip point, since here you can say, since delta V void is equal to delta V displaced, so H will remain the same. Got it? So this is how we derive the result for floating to floating condition. Now, as a fingertip point, you will remember whenever we have a floating to floating problems, because in MCQs or objective type problems, you would like to save our time. So whenever we have a floating to floating type problems, okay, suppose we have something like this, and floating to floating type problems will always be when the density of the object is less than the density of the liquid. Now suppose this is a wooden block which is floating, and we have another small wooden block A, and you know the density of wood is less than the density of water, and this is the water, and this level is given to be L, and this level is given to be H. And what you did, you simply pick up this pink wooden block, block A, and you have thrown it in the same container. So when you're picking up the wooden block and throwing it in the same container, and suppose you have a problem which says what will be the effect on the level, what will be the effect on the level of L and H. Now, since you remember the fingertip point, since wood has a density less than the water, so this wooden block will also be floating, right? This wooden block will also be floating. And now what do you think? So this level, say, will be L dash, and L dash will be less than L, correct? Simple logic. This bigger block will get lifted up because of a lesser upthrust. And what will happen to this H? So because the same removed object, which has been earlier over this bigger block, is still present in the same liquid and floating, so H dash is the new height, which will be same as before. Okay, so in such type of problems, don't take much time. Remember this key point approach. Whenever you have some object which was kept over some floating object, and this object has a density less than the density of the liquid, and you're throwing this object in the liquid, this object will also float in the liquid, and there will be no change in the level of the liquid, correct? So this will be something you can keep at a fingertip point for solving the problems in less time, okay? So that was something about floating to floating situation. Now let's come to floating to sinking problems. Now suppose we have a situation. Again, I'm considering a similar type of situation, but now the density of the object, say we have this a wooden block, okay, and now we have, say, a iron block of, say, mass small m, and the density rho b, and the density of the liquid is rho L, correct? So of course the density of iron, that is the density of the body in this case, is greater than the density of the liquid. So in this case, if you pick up this iron block and throw it in the liquid, it will not float over the surface, it will get sink, it will get deep sinking in the liquid. So let's see, if I'm picking up and throwing the block in liquid, okay, I'm throwing the block in liquid. So let's analyze what will be the situation and focus on the fundamentals, so that if any time you get confused, or if any time you forget a fingertip point, or if any new situation is given to you, suppose some additional object is brought from outside which was not earlier floating, and it is also dropped in the water level, and you have to compare the level, so you can do it if you know completely the fundamental and the analysis, okay? So say, first of all, we will remove and say this height is L and this height is H, okay? So I'm removing this iron block. So one thing is for sure, as we did earlier, this wooden block will get lifted up because now a lesser upthrust is needed to balance its weight. Earlier, the upthrust was balancing the both the weight of the iron block as well as the weight of the wood, as we have seen in the previous analysis. So one thing is for sure, this level L will decrease. Okay, this will decrease as we did in the previous problem. Now, since iron has a density greater than water, so your iron block will get sinked in the liquid. Now we will again analyze the two things. We'll find the volume which is getting free by the uplifting of iron block, that is delta V void, and this will correspond to the upthrust which was balancing simply the weight of the iron block as we did in the previous problem. So this, for finding this volume, actually this volume was earlier being occupied by both wood and iron. Now wood is still there, so only that much volume will get free, which was being occupied by the weight of the iron block. So V void density of liquid into G, and say mass of the iron we have taken as what, M into G. So we'll get delta V void is equal to mass divided by density of the liquid, correct? This will be the volume which is getting free. This is the volume which is getting free on removing the iron block, correct? And this is responsible, we have seen earlier, this volume is responsible for decreasing the height. Now what you're doing with this, you're throwing the block in the liquid. So what do you think? Apart from the volume getting free, will there be some other volume which will be getting further displaced by the block? Yes, of course. Now the whole block is inside, not like the previous case when the wooden blocks were partially floating in the liquid. Now because iron has a greater density, that makes the iron to get sink in the liquid. So the volume displaced in this case will be same as the volume of the iron block, and we know volume is mass upon density. Of course, the mass of the block is M, and the density is iron, say density of body. This is your second case, correct? And this volume will be responsible for what? This volume will be responsible for increasing the height. There will be, of course, two simultaneous effects, as we have seen earlier. What are the role of these two volumes? Now we know, since the object is getting sinked, so the density of the body is greater than the density of the liquid, and in both the fractions the numerator is same, so the fraction which has a greater denominator has a lesser value. So it implies that mass upon density of body is less than mass upon density of liquid, correct? So it will imply that delta V displaced is less than delta V void. The volume which is getting empty is more than the volume which is again getting occupied by the solid and getting displaced. So in this case, which effect will be dominating? Surely you can say decreasing H effect will be dominating, because the void volume is more than the displaced volume. So on the whole, H will decrease, correct? H will decrease. Got it? So whenever we have a problem like this, there is some object on the floating object. The density of the object is more than the density of the liquid, which will make the object to sink in the liquid. And when you throw the same object in the same container, L will decrease, and H will also decrease. Okay, both the factors, both the parameters will decrease. So this is something floating to sinking problem. Now, as a fingertip point, you can remember whenever we have floating to sinking problem, suppose this is wood and this is iron. So as a fingertip point for MCQs, you can remember this will happen when density of the body is greater than the density of the liquid, and this is your L and this is H. Now what you did, you removed the iron and you have thrown the iron, same block, in the same container. So what will happen? Remember two things. In this case, both this level L, say L dash, so L dash will be less than L, and this is say H dash, so H dash will be less than H. Both the level will decrease. Okay, so you just keep this as a fingertip point. Like see, we have an illustration. A wooden block with a coin placed on its top floats in water. The distance L and H are shown in the figure. This is your L, that is the level of the wooden block present inside the liquid, and H is the height of the liquid in the container. After some time, the coin falls into the water, then L decreases, H increases, L increases, H decreases, so on and so forth. Basically, the combination are you have to find what will be the relative change in L and H, correct? So we remember coin is metallic, coin is of metal. So in this case, the density of the body, which was earlier floating over the liquid, the density of the body which was earlier floating over the liquid is more than the density of the liquid, so it will get sink and no other changes is taking place. No some external object is brought or thrown in the liquid. So this is, we can simply apply our fingertip point, the end result, without wasting further time. In this case, L will decrease and H will decrease. Right now we have seen in such cases both L and H will decrease. So option D will be the correct option. Got it? Now suppose we say there is a large stone which is in a floating boat. What will happen to the water level if the rock is dropped in the water and it sinks down? Surely you can say, if suppose you are throwing the stone, it's a stone, not wooden balls. We have seen in case of the wooden balls, when you are throwing the wooden balls from the boat in the water level, the level of the water was same. But in this case, what do you think? What will happen to the water level when you throw this stone and the stone get sink down to the bed of the river? So surely you can say this level will decrease. This level, that is the level of the free surface from the bed will decrease, because stone or rock has a density greater than the density of water, so it will sink down. So we can apply the same analysis here. Now let's see the case of a melting solid. Okay, suppose we have some object. This is a third case. We have some object, okay, which is floating in the liquid with this much volume inside the liquid, say Vi, and the mass of the object is m, correct? So of course you can say the upthrust is equal to the weight. So Vi, density of the liquid, into G is equal to mg. So G will get cancelled away. So Vi will be m by density of the liquid, correct? So this will be the volume that is being occupied by the floating object when the object is floating, correct? When the object is floating. Now suppose it melts down. Suppose the object melts down. Suppose we have a cube of ice in a glass of water and the ice melts, correct? So when the object will melt down, it will be converted into the liquid state. Okay, the body will get converted in liquid state. And say the density of the body in liquid state be rho B L. The density of the body in liquid state, okay, be rho B L. We have to know this density. Now let's see, this was the volume which was occupied. This was the volume which was occupied by the object in the liquid. When the object will melt down, what will happen? This much volume will get free, correct? This much volume will get free. So we can say delta V void, the volume which is getting free, is same as the volume occupied by this solid when it was floating. So it will be m by rho of liquid, correct? M by rho of liquid. Okay. Now, when it get melted, it will be in the liquid state, correct? It will be in the liquid state, and it is still present in this container only. So the volume formed by the liquid state of the solid, volume formed by liquid state of melted solid. So what do you think? Say this volume is V dash. So it will be the mass, and the mass will remain same. The mass in liquid state will be same as the mass in the solid state. Let it be m by density of the body in liquid state, correct? So this will be the volume formed by the liquid state of the melted solid. Now this volume will displace the volume of the liquid in the container. Are you getting the point? This volume, which volume? The volume formed by melting of the solid in the liquid state. This will displace the original liquid. That is, this is some other liquid having a density rho L. Don't get confused with these two liquids. This is a liquid formed by melting of the solid. So this will displace the liquid of density rho L. So what will be the volume displaced? So you can say the volume displaced will be same as the volume formed by the liquid state. That is mass divided by density of the body in liquid state. Correct? So you got this is the volume displaced. Now we know the volume which is getting empty, this is responsible for decreasing H. The volume which is getting displaced further, this is responsible for increasing H. Now what will be the effect on H? It will be decided out of the two volumes which is dominating. So see case 1. If the density of the liquid is same as the density of the body in liquid state, then the volume which is getting empty is same as the volume which is getting displaced. So in this case, H will remain the same. H will remain the same, correct? There will be no change in the height of the liquid. This will be the case when the solid which is getting melted, has the same density in its liquid state as the density of the liquid in the container. Like if you say the illustration, consider ice block. We have a ice block in water, okay? And say this level is H. Now what do you think? Will there be any change when the ice melts? So when the ice melts, it will form water. This is the liquid state of ice. So here the density of the body in the liquid state is same as density of water. That is the water. That is density of liquid in the container. Okay, so there will be no change in the height. So when the ice will melt, this is a very important thing. Also keep it on fingertip. When the ice will melt, H will remain the same. If it is water, if it is some other liquid, then it will of course change. If you are considering the ice block in water, then there will be no change in the level of the water on melting of ice. Okay, this is the first case. Second case is if the density of the body in liquid state is greater than the density of liquid in the container. Density of body in the liquid state is greater than the density of liquid in the container. So if the denominator is more, the fraction will be less. So it implies that mass of density of body in the liquid state, is less than mass of density of liquid. And this is what? This is your void volume. RHS is the void volume and LHS is the displaced volume. So in this case, your displaced volume is less than the void volume. So what will happen? Surely you can say nothing new, no rocket science. Simply you can say this volume was responsible for increasing the height and this is responsible for decreasing the height and this is dominating. So in this case, the height will decrease. Correct? In this case, the height will decrease. Second case. Now you can do yourself the third analysis, the straightforward opposite of case 2. Case 3, if density of the body in liquid state is less than the density of liquid, so you can say mass of the density of body in liquid state is more than mass of density of liquid. So you can say delta V displaced will be more than delta V void. So decreasing H effect will be dominating. And so in this case, the height will, increasing H effect is dominating, displaced volume is more, so height will increase. Got it? So we got the 3 cases in the melting case. Okay, we got the 3 cases in melting. Whenever some object was floating like this, and if it melts and present in the same container, the height may remain the same, the height may increase, or the height may decrease. It will depend on the relative magnitude of what? The density of the original object in liquid state and the density of the liquid in the container. Got it? So this is the complete analysis for situations when we have problems like this. Some object was floating and it get melted in the same liquid. Now suppose we have a piece of ice and a stone is frozen in that piece. Suppose we have this piece and there is a stone. Okay. And this is floating in the liquid. How will the level of water in the vessel change when the ice melts? So see, this level is say H, and we have to analyze mathematically how this level H will change when the stone melts. When the ice melts, stone will still be present. Why it will be melting? Correct? When the ice melts. So see, one thing we have seen, since this is water, correct, and this is ice. So whenever the ice melts, it will not affect the level of the liquid. And if you want to do complete analysis from scratch, say the mass of the ice be Mi and the mass of the stone be Ms, correct? And the density of stone be rho s. Of course, your density of stone is greater than the density of water. And say this volume, which is occupied here, is Vi. So you can apply, and this level is say H. So we can say Vi density of the water into G is equal to mass of the ice plus mass of the stone into G, correct? So I'll get Vi as what? Mass of the ice plus mass of stone divided by rho of water. So when the ice will melt, right now, just assume that you're removing it. We are not melting the ice. Just imagine a model in which you are removing the ice block along with the stone. You are removing away the ice block along with the stone. So when you are removing the ice block along with the stone, there will be some volume which is getting free in the liquid, which was being occupied with this system. So this will be same as Vi. So that is Mi plus Ms by rho W, correct? Let it be equation number A. Now, actually that ice block has not been taken anywhere. It simply get melted in the same liquid. So when the ice will get melted in the same liquid, the stone will fall in the liquid, correct? When ice melts. So say this is the volume V1 formed by melting of ice. And since the density of stone is greater than the density of water, the stone will sink down somewhere deep down to the bottom of the container. And say this is V2, the volume of stone, correct? Now both this volume will be responsible. Both this volume will be responsible for displacing the liquid further. This volume, which has been getting free by the removal of the ice block, was responsible for making the free space, for decreasing H, correct? Void volume is for decreasing H. And this volume will be responsible for displacement of the further liquid. So it will be V1 plus V2. Now what will be V1? So mass of the ice will remain same, Mi, and the ice is in the liquid state, that is the water. So it will be density of water. And what is the volume of the stone? The mass of the stone divided by the density of stone. Correct? Let it be equation number B. This volume will be responsible for increasing the height H. Now let's see, compare both the volume, which volume is greater. So in both the cases, you can see if we split delta V void, so we'll get Mi by rho of water plus Ms by rho of water, correct? Now you can see in both the cases, one factor is same, one term is same, mass of ice by rho of water, mass of ice by rho of water. So which will be greater, whether the displaced volume or the void volume will be determined by the second factor. Whichever expression will have greater second factor will be greater in nature. Now we know rho of stone is greater than rho of water. So mass of stone by rho of stone will be less than mass of stone by rho of water, correct? So this factor, mass of stone by rho of stone, will be less than this factor. So you can add something same on both sides. Rho of water plus ms by rho s is less than mi. I'm writing the complete step, plus ms by rho of water. And this is what? This is your displaced volume. And this is what? The volume which got free by the removal of the ice. So you can see the displaced volume is less than the volume getting free. So on the whole, your height will get decreased. The height will get decreased. And this is the complete analysis. This is we did by complete analysis. So when we have an ice block with a stone embedded in it, stone frozen in it, and the ice melts, then the level of water, this will decrease. Got it? Now see one more illustration. No, this is not like floating to sinking or floating to floating. As I told you, if you know the fundamental, you can do any kind of problems, right? These are some problems we have done for the sake of application of the analysis. Suppose there is a woman sitting on the boat and the boat is floating in the water. Okay. So say this is the boat and this is the woman, and this level is H. And what she did? She drinks some water from the pond. Okay. So say she took, say the mass of this system is capital M, the mass of the woman plus the boat is capital M, and mass is the, a small m is the water mass drunk. Okay, what she has taken from the pond. We have to decide what will happen to the water level in the pond, whether it will decrease, whether it will increase, or whether it will remain the same. Now you have to apply the simple analysis, the same analysis, nothing new, no rocket science. Okay, if you know the fundamental clearly, you can very easily tell what will be the effect on the level of the water. Now see, when she is taking some water away, when she is taking some water away, there will be an empty space created in the water level, correct? Say delta V void. Delta V void. And this will be equal to the volume of the water taken by her. This will be simply equal to the volume of the water taken by her, that is mass of the water divided by density of water, correct? So this is the empty space which is getting created because she has removed this much water. Whenever you are removing m amount of water from any container, any pond, this much space will be created, and this will be responsible for what? This will be responsible for decreasing the level H. Now since she is drinking the water, So water has gone into her body. So the water will come in this system along with capital M, small m. So this boat level, this level will increase, yes or no? Because now the system has a greater weight. Along with the weight of the woman and the boat, now the system has also the weight of the additional water taken by the woman, right? So the upthrust will be more to balance this new weight. And so there will be increment in the volume inside this liquid. So now we have to find what will be the volume of the displaced liquid, correct? So this will correspond simply to the upthrust. Simply to the upthrust. This will correspond simply to the upthrust attributing to additional weight, because earlier also upthrust was balancing the weight of the woman and boat. Now we have to find the change in volume, that is the further volume displaced. So this volume we can write upthrust volume displaced density of water into G, and what is the additional weight? That is mass of the water into G. So G will get cancelled away and you will get volume displaced is what? Mass divided by density of water, and this will be responsible for increasing H, correct? This will be responsible for increasing H. Now you can see the volume which was getting free in the lake by the removal of water and the volume which is getting further displaced when C is drinking that amount of water are coming to be the same. Delta V void is equal to the delta V displaced, and since delta V void is equal to delta V displaced, so H will remain the same. There will be no change in the level of water in the pond. There will be no change in the level of water in the pond. Got it? So this was a lecture all about in doing the level problems. We have seen a lot of level problems, and moreover, more important than the kind of level problems, we have seen analysis, the fundamentals, how we do such problems by comparing the two volumes, the volume which is getting free by the removal or uplifting of some object, and the volume which is getting further displaced by the partial immersion, complete immersion, or melting of some object. And these relative magnitude of these two volumes will decide whether the level of the liquid in the container will increase or decrease. Got it?